Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. The joint probability function of x and y is 10x squared y for y greater than 0 but less than x and x less than 1. And we are asked to calculate the probability that y is greater than 1/3 given that x is greater than 2/3. And here's the solution. First, we note that probability that y is greater than 1/3 given that x is greater than 2/3 is the probability of both these events, x greater than 1/3 and y greater than 1/3 and x greater than 2/3 happening simultaneously, divided by the probability that x is more than 2/3. And we can calculate these two probabilities because we have the joint PDF of x and y. So we simply take the double integral over the region where what we want happens of the density, and we get these probabilities. What's the probability that y is greater than 1/3 and x is more than 2/3? Well, x runs from 2/3 and 1, and for any fixed value of x between 2/3 and 1, y has to be less than x, because that's one of the conditions for the density to be positive. And y runs from 1/3 to the value of x. That's where y is more than 1/3, but less than x, which it has to be for the density to be positive. And the joint density is 10x squared y, so we take the integral with respect to y first and then with respect to x. So we do this integral with respect to y first, and we get 5x squared y squared as the function whose derivative is 10x squared y with respect to y, of course. So we evaluate this function from y equal to 1/3 to y equal to x, and then we take the integral of the result from 2/3 to 1 with respect to x. Okay. Well, what is that difference of values from 1/3 to x? At x, this expression is equal to 5x to the 4th. And if we plug in y equal to 1/3, then what we get is y squared is 1/9, so we subtract 5/9 x squared, and we take the integral of this expression from 2/3 to 1. And what is that? Well, we take the integral with respect to x, so the integral of 5x to the 4th is x to the 5th. And the integral of minus 5/9 x squared is minus 5 over 27 x cubed. And we evaluate this whole function from x equal to 2/3 to x equal to 1. At x equal to 1, obviously, this is 1 minus 5 over 27, which is 22 over 27. And at x equal to 2/3, well, we would have 2/3 to the 5th minus 5 over 27 times 2/3 cubed. And once you evaluate that, you'll see that you'll get 56 over 729. And 729 is equal to 27 times 27. So 22 over 27 is equal to 22 times 27 over 729. And therefore we have a common denominator, and we simply take 22 times 27 minus 56 over 729. And we end up with 538 over 729. That's the probability of the intersection of those two events. Then we calculate the probability that x is more than 2/3 as a double integral again. You don't have to do it this way. You could also find the marginal density of x and then find the probability, but this is one calculation, so I decided to do this. And we just take the integral of the joint density over the region where x is more than 2/3. So x therefore runs from 2/3 to 1, and then y has to be less than x. And therefore it runs from 0 to x. The joint density is 10x squared y dy. And then after we do this integral with respect to y, we get the result and take the integral of the result with respect to x. Okay, so that's 5x squared y squared evaluated from y equal to 0 to y equal to x. Integral of that from 2/3 to 1 dx, and that's integral from 2/3 to 1 of 5x to the 4th dx. Of course, that's x to the 5th. 5x to the 4th is the derivative with respect to x of x to the 5th. And we evaluate x to the 5th from x equal to 2/3 to x equal to 1. Well, that's equal to 1 minus 32 over 243, or 1 is equal to 243 over 243, so this becomes 243 minus 32 over 243. That's 211 over 243. And therefore the probability we're looking for is the ratio of the two probabilities we just calculated, 538 over 729 divided by 211 over 243. Well, actually, 3 times 243 is 729, so we can just cancel out the 243, and we are left with 538 over 3 over 211. 3 times 211 is 633, so this is equal to 538 over 633, and that's approximately 0.84992101, which is answer C. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.